welcome also from my side. I'm very happy to see some of you online here. We did these two webinars to cater for the different time zones. I see that people from different time zones are joining, so maybe we are. Let's see how the next one will work out. But very great to have you all here, and just to, I think, convince you a bit more, because I think, at least from the names that I see, I think most of you are very much convinced by ISIMIP and by the approach. I just wanted to give you this quote from the AR6, chapter 16. That why we are doing this, why it's so important to actually focus now on these changing simulations with changing direct human forcing. And that's of course because many of the key risks that we are relating to climate change, so impacts on human health, impacts on peace and mobility, food security, so they are all by definition, of course, cross-sectoral. And they all depend on a changing future. And that's what is encapsulated in this quote here, which says that representative key risks are expected to increase in the coming decades and will depend strongly not only on how much climate change occurs, but also on the exposure and vulnerability of society changes. And you see how much climate change occurs, that's usually the hazard component, and of course this vulnerability and exposure component is changing as societies change. And then there's a second part of the sentence which highlights adaptation efforts, and that's also very important because they also relate to changing societal conditions in a sense, and that's why we need all of this. Next slide, please. Yeah, and then just to bring it home, basically, yeah, so you see with ISIMIP3b Group I and Group II, we were basically doing the hazard, and now we are adding the vulnerability and exposure component. And actually, it's really a nice integration of different problems, yeah, I think, that come along with these changing future socioeconomics. Yeah, so on the one hand, we can integrate impacts of mitigation measures and climate impacts that remain. Yeah, so for example, the new climate the new direct human forcing that you will see includes bioenergy, crop demand, land demand, and hydropower dams, and so on. So the effects of mitigation measures can be included. And then we have adaptation, no adaptation setup that will be explained later. And in this setting, then actually it's not only about, let's say, autonomous adaptation, but there's really in some sectors explicit adaptation measures considered, like seawater desalination and AC deployment and so on, that actually allows us to study those in more details with these Group III simulations. Next slide, please, Katja. Thanks. So we have, just to give you this now as a graphical representation, we have Group I and Group II in the past, and they are characterized by historical climate forcing and observed direct human forcing, and then future projections and constant future direct human forcing. Katja, if you can go to the next slide, thanks. You see this here, you have seen this sketch quite a lot, yeah, and this is, I think, what you have been doing also, most of you that are modelers. So you have changed the climate forcing using different SSP, RCP combinations, but you have kept the direct human forcing constant in the future, as you see in the upper part of the figure. And if we now move to the Group III figure, Katja, yeah, you can move to the next one right away, then you see that we now have also varying direct human forcings that follow the SSP conditions, and then also an adaptation case where there's not only the SSP conditions, but also the climate impacts from the sort of SSP-RCP combinations coming into the logic. And this is sort of the simulation logic that is behind the Group III simulations. And I think you should have seen this all a lot, but now all the new things start and the complicated stuff. So I hand over to Katja, and hopefully until here you are all sort of well informed. Otherwise, of course, feel free to use the chat to just ask quick questions of understanding, and then we will clarify them. But now, Katja, please go ahead.
Okay, so I'm happy to present part of the data sets and also a more comprehensive overview, but just a few examples of what is changing now in the Group III simulations. So kind of the basic forcing is the population and the GDP change. And that is only SSP dependent, so not depending on the climate. And you can see here the different SSP storylines we consider within ISIMIP. So yeah, the 3 ones you are, yeah, we selected all together basically. And these projections also determine at least partly the land use changes, for example, because they are designed to meet the food demand, for example, that is growing with growing economic development and population, for example. So that's what you can see here on the top, where the agricultural land for food production is shown. And we consider 2 scenarios, one where climate change, so the impacts of climate change on crop yields are accounted for, and another set where it's not accounted for. And Jakob will go into more detail with regard to the distinction between the adaptation and no adaptation scenario later. But what is also important to always have in mind that we also account for the mitigation measures that are associated with the different climate scenarios we consider. So here, for example, you have different demands for bioenergy. If you want to reach a very low emission scenarios, it needs more bioenergy areas. So the green line here, and that is also accounted for in our land use patterns that are provided for the Group III simulations. Another example of forcing data we provide is hydropower dams, and that's also depending on the mitigation measures. So it clearly dependent on the hydropower demand. And I just briefly wanted to illustrate that. So you can see here for different regions in black the hydropower demand for the high emission scenario. And in red, the cumulative potential met by the hydropower dams we provide as forcing in the Group III simulations. So this is also another example where mitigation and adaptation climate impacts are somehow integrated. So the list of climate direct human forcings is much longer now, and I want to go through this table to let you know what we can provide now. And there's one important definition with you already know from other settings, and that's whether a dataset is considered mandatory or not mandatory, so optional for the Group III simulations. And mandatory again means so if you have an impact model that accounts for that measure at all, then you have to use the specific data set. So you can't use an alternative one if you really want to do Group III simulations. And this is indicated by mandatory or no mandatory. If this data set is not at all relevant for your impact model, then of course you do not have to include it. And that's, yeah, so mandatory is really meant in this way. Yeah, and now I want to present you all the data we have collected over time. So in green is what is really now available, and in yellow, which is still under construction, but quite close to becoming available. And the green ones are at least yeah, sufficient to start some of the sectors, and that's why we decided to do it now. So for the GDP data, you've already seen the aggregated national GDP data, but we will also provide gridded data. So this is still under construction. And this will be mandatory because this is kind of the basis for the entire harmonization and consistency within ISIMIP. So it will be a gridded population and gridded GDP data we will provide as mandatory forcing, and national data, of course, too. Then there's some information that is probably highly relevant for all agriculture-related simulations. So there will be protein uptake from the land use models, because this is the kind of the demand they are trying to meet by adjusting the land use patterns. So this is also provided. And then more important probably is the land use change that is direct impact input to many of the different impact models across sectors. So that's really the fraction of a grid cell used for example, wheat production. And irrigation is also available on grid level, saying how much of the grid cell is irrigated. And then we also have wood harvest information from all this is now available. I forgot to say it's now available from 3 different land use models. So in ISIMIP3 we only had that information from 1 land use model, but now we are able to also account for some of the uncertainty associated with the different assumptions within the land use models. And we get all that information from MAGPIE, Globion, and Image. So, and that's probably the main land use models that are able to produce these gridded data sets we need. So in addition to the standard input we already use and provided in the Group II simulations, we now also have wood harvest and land transformation information. And synthetic fertilizer input is also available for different groups of crops. And now what is new now is that we do not only have the nitrogen fertilizer information, but we will also get information on phosphorus inputs for cropland and grassland separated. That's not yet available, but already under construction. And before we only provided the information on synthetic fertilizers, but now we also have we will also get information on annual manure, nitrogen and phosphorus input. So this is also new and highly relevant, I think, the phosphorus information for the water quality sector. So we hope to make them happy. And we will also have livestock numbers, which is new. So, and this is also under construction already and not, so it's really in reach. So probably after the summer break, the data will become available. Then we have total nitrogen deposition as before already, and that's more or less our standard input data set. And we are now only checking whether we can also get separate information for wet and dry deposition, but that's something we still have to clarify. I think most models can already work with the total N deposition we provided before. Then we have a crop calendar describing the adjustments of growing seasons in response to climate change. That is also available, generated within the agriculture sector. And then for FishMIP, we will also account for changes in marine fishing efforts, and that data set is still under construction. So green here really means that all that is already available on the DKZ server, and yellow means under construction, available soon. And then dams and reservoirs, that's the slide, the figure you've already seen. So changes in dam locations in response to growing hydropower demand and climate change. And then there will be information on non-irrigation water use that is also still under construction. So in domestic industrial water use. Then we have data on seawater desalination and interbasin transfer that is already available, and irrigation technique shares will become available too for different scenarios. And then there's one data set that is only relevant for the regional forestry sector. So, and that's forest management, a more rule-based approach describing how forest management will change with a focus on Europe only. And then for the energy sector, we will also get residential air conditioning and energy consumption by air conditioning. And that's the data set we, so again, the green ones that is already available and will allow many models to start now, and the yellow ones becoming available. And what is now a Group 3 simulations needs some more definition, because within a sector, it's important to somehow harmonize the different measures, so the changes in direct human forcing that are particularly relevant for your sector, and you want to account for as a minimum. So and that has to be specified also for the users of the data later, so that they know if they use a Group 3 simulation, then at least these measures are somehow considered in the models. And that's why we have this table in the protocol, where, for example, here the measure is considered, its land use changes, and then here we specify in which of the sectors this is really considered a required measure. So if you do not account for land use changes within, and you belong to one of these sectors, then your simulations won't count as a Group 3 simulation. And then in a sector specific, you can also show the sectoral coordinators together with the modelers have agreed on whether they want to harmonize that specific measure or not. And for example, for land use changes, there's not so many choices. You basically have to harmonize the land use changes, because the land use change data sets are mandatory. So you are basically not allowed to use an alternative data set if you account for that measure. But you could also imagine that you want to harmonize the implementation of a direct human forcing within your sector, although the data set is only optional across sectors. And then that could be specified in this table here. So yeah, I forgot to switch the slides. So one in the first column, you say, well, you have to account for these measures at all. You can do it based on the data sets we provide, but you somehow have to account for it, maybe also in your in a best guess approach for your model. But if the data set is additionally harmonized, then you have to follow the rules and use the data set that is provided by ISIMIP. Okay, and then we come to the difference between the adaptation and no adaptation experiments explained by Jakob.
Yes, so oh wow, I hear an echo. Maybe you can mute, Katja.
Oh, sorry, yeah.
Thanks. So just, now I don't see the presenter mode anymore, but maybe it doesn't matter. Yes, now we're back, thanks. So no adaptation means all these direct human forcings still change over time in the future, but as if the climate wouldn't change. Yeah, so all the other drivers except climate change, they still change. Yeah, so population and GDP and everything else. So it's really assuming a world that develops over time, but there's no climate change. And then in the adaptation case, climate change is added and taken into account in whatever decisions, let's say on land use or hydropower dam construction or any other of these direct human forcings and measures. So that's the very, I would say, concrete and pragmatic definition of adaptation that we have adopted. And that means that adaptation is really represented directly through these different forcing data sets and assumptions. So you really have, for many of the direct human forcings, you have two different versions, yeah, a no adaptation version and an adaptation version, and switching between. So when you do your no adapt run, you just take the one data set. When you do the adaptation run, you take the other data set. That's basically what it boils down to, except in cases where there are additional assumptions in a particular sector that are not represented just by data sets. And just, yeah, thanks. To give an example, again for the hydropower dams, how this would be constructed. So to come up with these hydropower dam scenarios, we have a hydropower potential model that that really evaluates all the different potential locations where you could build a dam, and then calculates how expensive that would be and how the dam would look like and so on, how high, how long, how much water would be stored, whatever, how much the electricity costs. And that model needs as input the river discharge, and that in turn comes from a global hydrological model. And that global hydrological model, of course, needs to be driven with weather inputs. And the difference between the no-adapt and the adapt case is that in the no-adapt case, this weather input comes from the reanalysis data set and really represents present day or recent climate conditions. Whereas in the adaptation case, we take future projected weather conditions from the climate model. And so these two different forcings go into the model chain, and then we end up with different projections of potential hydropower dam locations. The other inputs that mainly enter through the hydropower demand, because then the potential locations need to be mapped to the actual hydropower demand that needs to be satisfied. And that comes from an IAM, integrated assessment model, which in turn, of course, the demand depends on whatever population, GDP, but also the composition of the energy mix and so on. And that all these things that don't depend on climate, they are the same between no adapt and adapt. So it's really just the river discharge input, basically, that is the difference. And you could imagine that in the no adapt case, the hydropower planners and policymakers, they don't know about climate change, for example, even though they know about it's in some way a counterfactual world, of course, because they still want to mitigate. So the demand corresponds to the mitigation targets, but they don't know that climate change will impact river discharge. So they build the dams as if the discharge would stay the same. And in the adapt case, they anticipate that also the discharge will change in response to climate change, and so they will decide a little bit differently. And if you switch to the next slide, we can see some examples of what this difference actually looks like in the concrete data. So this is for two different regions, and the same kind of plots that Katja already showed, with the demand in black. And then each red point is one newly constructed dam to satisfy, help satisfy the additional demand. And when you compare these regions, for example, in Europe, you see some difference in the order, and so you can imagine the vertical difference between 2 points is kind of the additional capacity that's added by one dam, and that looks different. Yeah, so apparently a different number and different dam locations, different capacities, and so on are selected in adapt compared to no adapt. And also sub-Saharan Africa, you see that actually there are more dams need to be built in the adapt case to satisfy the same demand compared to the no adapt case. So apparently the discharge changes in a way that makes it necessary to build more different dams in addition. And then when you go to the next slide, I quickly want to explain how now to decide in which order to run your simulations. So next slide, because there's, as you might have guessed by now, there's many different possible combinations of all these different forcing data sets. Yeah, so we have the climate-related forcings from the different climate models. We now newly in the Group 3 simulations have 3 different land use models, so that's an additional dimension. Then we have 3 different SSPs that we consider, and also new in Group 3 we have adaptation versus no adaptation. And so we have come up with a priority list to try to fill this multidimensional matrix bit by bit, starting with sampling each of these dimensions partially, so that even if you can only do, let's say, 12 simulations, then please do these 12, and then everybody does at least these 12, and then we have a rather harmonized set of simulations across the different sectors that samples all these dimensions of uncertainty or of variation, at least to some extent. Yeah. So for example, in this core set here, we start by cycling through these 3 different land use models, just for one climate model, one SSP, and just for the no adapt case. But so at least we can see what difference does it make if I use this land use model or that land use model. Then we do one run with the adaptation case, just to be able to see, to compare adapt and no adapt. Then we cycle through all the GCMs, and then we add other SSPs and again adapt and no adapt. Yeah. So this is a core set that I think satisfies many potential research questions already, and is kind of a minimum that we hope that everybody will be able to do these 12 simulations. And then when you go to the next slide, the remaining possible combinations, which are close to 190 combinations, we have also sorted them in a way that we relatively systematically cycle through the different dimensions. And so if you are able to do more than 12 simulations, which we hope, then just follow this list. Yeah, you can do one tier after another and one run after another. You just go down this list, it's in the protocol, and then we have the largest possible harmonization between all the models. And then the final slide, maybe a question that many people have in mind: are you ready to go? And we have, so Jochen has implemented in the protocol these nice symbols here that you see on the right-hand side, so like a traffic light system. And obviously when it's green, it means your sector is all ready to go. All the models can start, the protocol is online, and all the input data is available. When it's half green, half yellow, then that means some models in the sector can start, but some models may still need to wait because some input data is still missing. And this concretely is true for these 4 sectors here: biomes, fire, peat, and permafrost. And actually most models in these 4 sectors should be ready to go. Only, there are some models, for example, that need gridded GDP as an input, for example, in the fire sector, and they need to wait a little bit until we have that gridded GDP data set. Yeah? And there are some other of these examples. But if you are in one of these sectors, please go and check in the table in the protocol. It's quite likely that you can start your simulations right now. And then there's a yellow, which means this sector is not ready yet, but will soon hopefully be ready. There's just some open issues in the protocol and or some data still under construction. And I think that's it. And we now have time for your questions. And of course, if you later still have more questions, then you can of course always write to us. But now is specifically dedicated to any questions you might have already now. Thanks for listening.